So the fifth section in your notebook is volume, and we did this right before we started review, so maybe you'll remember volume and area. So the 2012 says you've got the R, gives you a graph of it. It gives you the function rules, y equal ln of x, y equal 5 minus x. This is a calculator active. Some of these are and some of these aren't. It says find the area of R. So remember, you either go top to bottom or right to left. If you go right to left, you would use y intervals and you'd have to convert the equations. If you use x intervals, notice there isn't a clear top to bottom, so you'd have to stop right here and just do individual ones. So that's what I did on this. So I put these in my calculator and got my intersecting points. And so I'm going to go from 1 to this intersecting point, and this curve is the ln of x plus that intersecting point 2, 5 is 5 minus x. So notice I have to do that because there's not a clear top to bottom. And if you put that in Math 9, you get 2.986. Now it says region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Right, but do not evaluate an expression that gives the volume of the solid. So remember with cross-section, square is side squared, and so you're going to do each individual one again because I don't have a clear top to bottom. So I'm going to do this. This is my square side, so that'll be squared plus this squared. The horizontal line y equal k, so I've drawn that, divides R into two equal areas. Write but do not solve an equation involving the integral to give the value of k. So you want to have k in it. So you're going to go from 0 to k. Now why am I doing 0? Because k is going to be a y interval. So we're going to have to use y intervals. So since we're down here, the y interval is 0 to k. Now, because we're using y intervals, we're going from right to left, and we'll also have to convert. So I'm going to convert this to an x equal equation and convert this to an x equal equation. So if I do that, it's just going to be e to the y equal x. And then if I do that, it'll be negative y plus 5 or 5 minus y. This line is right and this is left. So I go 5 minus y minus e to the y equal 1/2 of the area that we had because we know the whole thing. So that's how you would do that one. 2011 one is a no calculator, and they give you the picture of the graph, and they said let R be the region of the first quadrant. They do give you the function rules, and it says write an equation for the line tangent to the graph of f at x equal 1/2. Well, remember, you've got to have an ordered pair and a slope. So you have f of x, so you're going to get the derivative using your power rule. You're going to put 1/2 in, and so you're going to get 6, and then you're going to plug it in y mx plus b and get b, and so your answer is 6x minus 2. Now part B says find the area of R, so we're going to use x intervals, and we're going to go top minus bottom. So we got 0 to 1/2 sine pi of x minus 8x cubed dx. But we have to do it manually. So remember, you got to do u equal pi x, du equal pi. So if we negate it, we're going to have 1 pi sine u. And this one, I'm just pulling out the 8x cubed dx. So the integral of sine is negative cosine. So I got negative 1 pi cosine of pi of x, 1/2 0. And then if I do my power rule, I'm going to get 1/4 x to the 4th. And so if I plug 1/2 in here, I get cosine of pi over 2, which is 0, minus, if I put 0 in here, cosine of 0 is 1, but minus would be what? Plus. Then minus 8 times 1/4 is 2. If I put 1/2 in here, I get 1/16 Obviously 0 would just be 0. So I get pi 1 over pi minus 1/8 as my answer. That says write but do not evaluate integral expression for the volume when r is rotated about the horizontal line y equal 1. So remember, if we're going up on a line above, you're going to subtract the line from the function. But if we're going up, the bottom's going to become the top. So we're going to do the 8x cubed first. So we're going to go 0 to 1/2, and we're doing 1 minus 8x cubed squared. And then over here we're going 1 minus sine pi of x squared dx. So remember, if it's above, it's whatever the line minus the functions, and then it'll reverse the order. The bottom will become the top. Now the next one, 211, form B. Again, you cannot use a calculator on this. They give you the function rules, and they give you the drawing. And it says find the area of R. Again, there's not a clear top to bottom, so I'm going to break it up. So I'm going to go 0 to 4, square root of x for this one, and then 4 to 6, 6 minus x. And I have to do this manually, so I'm going to make that be x to the 1/2, which will be 2/3 x 3/2 when I do my power rule. This will be 6x minus x squared over 2. Now, remember, you're on a non-calculator, so I made that 3/2 be 1/2 raised to the 3rd, because square root of 4 is 2, 2 cubed is 8, and then I can multiply that by 2/3. That makes it easier. Minus 0. Then I'm going to plug 6 in, 4 in, and when you combine all that, you get 22/3. So part B says the region is a base of a solid. From 0 to 2, the cross-section of the solid is perpendicular to the y-axis, is a rectangle whose height is 2y. Write but do not evaluate an integral expression that gives the volume of the solid. So, because it's perpendicular to the y-axis and they give you y intervals, we are going to have to do y functions. So, we know it's 2y, and then it'll be times your function. So if you're doing y intervals, you're going right to left. So if you've got y equals 6 minus x, if you convert that to an x equal equation, you get 6 minus y. And if you've got y equal to the square root of x, and you solve for x, you get minus y squared. So that's the base of the rectangle times the height. Now, part C says there's a point P on the graph of F at which the line tangent to the graph of F is perpendicular to the graph of G. Find the coordinates. So what do you know about tangent line? You need a slope and an ordered pair. You've got an ordered pair. What do you know about the slope? Well, you know that its tangent is perpendicular to the slope of G. So I'm going to come over here and do G prime, which if I do, I just get -1. Well, if I'm perpendicular to -1, my slope's going to be 1. So then I'm going to get the derivative of f, because that's my slope, and that's 1/2 x negative 1/2. So I'm going to write it as 1, 2 square root of x. I know it's got to equal 1, solve for x, and I get x equal 1/4. And so now it says, what will the point be? Well, I know that my x value is 1/4, so I just plug 1/4 into f, my original function, which was the square root of x, and I get 1/2. So my point is what? 1/2, 1/2. So that's using just information you know to get down to an ordered pair. And the next one's the 2010, no calculator involved. It gives you a drawing. It gives you the function rules. Find the area. So we're going to go top to bottom. We're going to use x intervals. So 0 to 9, 6 minus 2 square root of x dx. We're going to do this manually. So that'll be x to the 1/2. That'll be 6x. And then that'll be 2/3 x 3/2. And if I plug 9 in there, I get 54. Again, because you're on a non-calculator, I'm going to make the 3/2 be 1/2 cubed. So if I put 9 in there, that'd be 3. 3 cubed to be 27. And I can multiply that out and get 18. B, write but do not evaluate an integral expression that gives the volume when r is rotated about the line y equals 7. Okay, 7 is above, so remember we're going to subtract, and this will become our top, and this will become our bottom. So we're going to put pi 0 to 9. So we're going to say 7 minus 2 square root of x squared minus, and then we're going to do 7 minus the 6 squared. And region R is the base of a solid. We're doing y intervals. The cross section of the solid is perpendicular to the y-axis, is rectangular, whose height is 3 times the length. So again, we're using y intervals. We're going to go right to left. Well, if you go right, it's this curve, and left is just y equals 0. This line's not even going to come into play. So we're going to come over here and convert this to an x equal equation. And it says that the height is 3 times the length. So we know the length is this, and then 3 times that. And then you could leave it like that, or you could simplify it, and that would be the integral. So I hope you understand why this doesn't even come into play, because you're going right to left. So this is your right curve, and your left curve is just 0.